Hello, my name is Laksmita. I'm from IUP class of Structural Geology, Geophysics Engineering ITS. And in this video, I would like to present my HCS answer. First is about basic concept of structural geology. So, structural geology is a scientific discipline that is concerned with rock deformation on both a large and a small scale. Its scope of study is vast, ranging from submicroscopic lattice defect in crystals to fault structure and fault system of the earth crust. So the methodology that usually used in structural geology is first, measure rock geometries, second is reconstruct their deformational histories, third is estimate the stress field that resulted in that deformation. So the example of the methodology is draw and estimate the strike and dip direction. Next is estimate joint the joint shape or joint size. Next is measuring the thickness and the depth. And then how about the stress and the strain, and etc. Next is strike and dip. So strike is the direction of the light from the intersection of the planar plane with the horizontal plane in terms of a north. A planar plane here is a relatively straight plane, and in this case, it is a muscular plane. We can see here in the figure. So strike is a horizontal direction like this from east to west. Next is dip. Dip is the angle between the planar plane and the horizontal plane, whose direction is perpendicular to the strike direction. This is the strike, and the dip is between, like this. And I want to warn to you that dip must be measured perpendicular to the strike direction. Must. Okay, so writing strike and dip direction. Let me take the example. North 30. Okay, wait. North 30 degree is dip 40 degree. Okay, so we read this north to east 30 degree and 40 degree for the dip value. We can draw this direction north 30 degree. So example, this is the plane, and then north 30 east. So we tarik garis like this from this to this, 30 degree. Okay, so the dip direction must just draw like this, and it must be perpendicular with the strike direction. Okay, this is so simple. And strike and dip in rock layer usually measured with geological compass. Next is joint. Joint is a crack in the rock whose side doesn't experience movement and often become a place for fluid to flow. And usually, joint is characterized by the presence of certain mineral veins resulting from precipitation of crystallization of the solution. Okay, so in this table that I made, there are 4 classification of joint. There are joint based on the shape, kind of joint on shape, based on size, based on the process of occurrence, and the way it happened. So the kind of based on the shape, there are systematic join and non-systematic join. From size, there are master join, major join, minor join, and micro join. Based on the process of the occurrence, there are shear join, tensional join, sheet join, and shrinkage join. And based on the way it happened, only two: first order join and second order join. Okay, next is about thickness and depth. So thickness is the shortest distance measured between two parallel planes, which is the boundary between two layers. Depth is the vertical distance from a certain height to a point. For example, is the sea level to a point or plane. Okay. The direct thickness measurement is applied when the topography is perpendicular to the slope of the rock. We can see here in the figure. So the thickness is the shortest distance of this is the thickness, the boundary between two layers. This is layer 1. This is layer 2. Yeah, like this. So the thickness is the distance of this. Like this. Okay. Next, the depth. The depth is measured from vertical. This is the depth. For example, this is the plane, and the depth is from the top to this. There is a boundary, so the depth is just from this from to this. Just like that. Okay, next is stress and strain. So stress is a force that can cause changes in rock. The simple way that we say stress is a force per unit area. And stress divided into two types. First is uniform stress and differential stress. We can see here in the figure uniform stress. Uniform stress is stress with the same magnitude from all directions. Okay, this is the stress, this is the stress, this is the stress, and the magnitude of this stress all is same. Different with the differential stress. If differential stress, okay, this is the stress, this is the stress, this is the stress, and the magnitude of each stress is different. For example, this is intermediate stress, this is minimum stress, and this is maximum stress. So each magnitude of the stress is different. And differential stress divided into three types. First is tensional stress. Second is compressional stress. Last is shear stress. All has the opposite direction, only different in the last deformation. Okay, next is brittles and ductiles. So brittle is a fracture in rock caused by small deformation on strain force. Rocks brittles are in nature are usually called competent, and rock brittle usually crack or rupturing of a body under stress. So we can see here in the figure. So brittle is cracking, patah. Okay, next is ductile. Ductile is a rock that is subjected to deformation and indicates that the strains are evenly distributed, capable of being molded and bent under stress. So, in ductiles, rock usually referred as incompetent. So, we can see here, brittle is not cracking, right? It can be bounced back if the stress is gone. Okay, so brittle and ductile properties are influenced by confining pressure, temperature, and strain rate. Okay. Next is foliation and lineation. Foliation is planar structure in metamorphic rock as a result of the influence of differential pressuring during the metamorphism. And the kind of foliation is slaty cleavage. This in the figure. Slaty, fillet, schist, and gneiss. So, first is slaty. Generally found in very fine grain, microcrystalline metamorphic rock, which are characterized by the presence of very tight, regular, and parallel planar planes. The rock is called batu saba or saba rock. Next is filletic. So filletic almost the same as slaty cleavage, but the recrystallization is greater than separation of flat mineral with granular mineral is visible. The example of this filletic is fillet rock. Okay, next is schist. Schist form a parallel arrangement of flat, prismatic, or lenticular mineral, which are medium to coarse grain size, and the rock is called schist. Next is gneissic. Next is gneiss. Okay, so gneissic formed by alternating mineral alignment layer that have different shape, generally between granular minerals, feldspar and quartz, and tabular or prismatic mineral, intermittent. And the rock is called gneiss. Next is lineation. Lineation is the terminology of a linear structure in a material, such as a flow line, a parallel arrangement of sedimentary material on a sedimentary rock, or on a fault axis. There are two types of lineation. First is the primary line structure, include the lineation or alignment of mineral contained in certain igneous rock, and the direction of the lineage of the sedimentary structure. Second is secondary line structure, include longitudinal lines of fault, breccia, fragments, straight of rivers, fault, axis line topography, and others. So, in this figure we can see this is the foliation and this is the lineation. And lineation usually we can imagine from a drinking straw like this. This is the lineation. Okay, the last is unconformity. So unconformity is an area of misalignment between layers, And there are four kind of unconformity here. First is angular unconformity, which appears to show a layer that has been folded and eroded. Then another layer is deposited on the top of the layer. And the simple way, angular unconformity has a like this, like a different way, and it has a angle. Next is disconformity. Disconformity appearance is in the form of an eroded layer, and another layer is deposited on the top of the erosion area. So this is the first area, okay, and this is another layer that deposited on the top of the erosion area. Okay. Next is paraconformity. So paraconformity is also called like shadow alignment, which show a layer above and below it that is parallel. And in this area of misalignment, there are no physical signs to distinguish. So yeah, it's just like this. To determine the difference, we using the age range of the fossil. So we use a paleontological analysis in this paraconformity. Okay, the last is nonconformity. So nonconformity occur where there is clear contact between igneous rock, sedimentary rock, and metamorphic rock. Okay, the difference is very clear. Okay, I think that's all from me. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.